Hey everyone, Katrina here, and today I'm going to explain to you what is a radian. Be sure to subscribe for more videos and watch to the end to see our example. Okay, so in trig, we have some angle, right, that we're usually dealing with, and an angle can either be measured using degrees or it can be measured using radians. So in some of my previous videos, I showed the conversion of how to go in between degrees and radians. But we might be wondering, what exactly is this radian and how did this measurement come up? And I'll tell you right now that it's not arbitrary and it actually has a really cool derivation that we're going to see today. So in order to understand radian, we first have to understand what is the arc of the circle. So the arc of the circle is, we can specifically have an equation for it. So the arc of a circle, if you denote it as A, equals to the radius of the circle, which is half the diameter, multiplied by the angle, which is in between the two radius segments in question. So if we look at our image over here, we have our two radii drawn. In green, we have our theta, the angle between them. And then this piece of circle, this arc over here that connects the two radii, this over here is going to be the arc, which is denoted as A. So now we have our equation to actually find our A. Okay, well, how does this relate to radians? So this is where the interesting part comes in. So if we have that our length of our radius is equal to the length of our arc, okay, so we're saying that the arc here is equal to the length of our radius, then our theta is going to be equal to 1 radian. And that's how radians were born. So if your radius is equal to the arc, then this theta over here is going to be equal to 1 radian, which is really, really cool. So let's kind of look at an example. So let's get that ready. So say, for example, what can we do here? What if our radius is, so I'll show you. So what if we're going to say that our theta equals to 1 radian, and we're going to say that our radius is equal to 5. Let's see what the arc length is. Well, if we follow the formula, we have that A equals to R theta. So then as a result, we'd have that arc length equals to 5 times 1, which equals to 5. And then you can quite easily see that the radius is equal to the arc length, and which makes sense because our theta was 1 radian. What if we do another example where we say that theta equals to 2 radians? So again, we don't actually have to write out radian for angle. If we just write out 2, then it's assumed that it's radian because you're not specifying degrees. And we'll say again that radius equals to 5. What is the arc length going to equal to? Well, A is going to equal to R times theta, so 5 times 2, which equals to 10. And we can see that 10 is twice as big as 5, and our radian is 2, not 1. So we can see that direct relationship there between our theta, our radius, and our arc. So that's really neat. Hopefully this video gave you some background of what a radian is and how you can connect it to the information to the radius as well as the arc of your circle. Just fun to dive a little bit deeper into trig and really understand what you're doing. If you enjoyed this video, please drop a like and definitely subscribe for more. I look forward to seeing you next time.